Hello everyone. In this video, we'll be discussing about performing a clustering and dimensionality reduction for a particular use case. So I've been given with the use case on drug discovery. So let us see the code section with the dataset. So initially for the clustering task, we have to import all the necessary packages such as pandas, numpy, matplotlib, seaborn for visualization, matplotlib also for visualization, and then sklearn.cluster for importing uh, clustering task. So here we are going to use k-means clustering, and we are importing sklearn.preprocessing standard scaler. Initially, we are importing the CSV file into a workspace through the command pd.read underscore CSV of the path. And then this section of code is for removing the blinded values in the target axis. Like this is our target variable PIC50. So we can see lot of values such as blinded over here, that is string values which cannot be processed as such. So we have to replace those values with some other numerical values in order to process the data. So here we are replacing the blinded values with the numerical data. And then this section of code is to convert this complete target axis or complete target variable into zeros and ones and then proper numerical data by taking mean of all the values present in the dataset of PIC50 column. And then in this section of code, we are going to import standard scaler which scales the values of the data within the particular range. And after importing the standard scaler, we need to fit the standard scaler for the numerical features. And then we have to initialize the k-means algorithm over here. So we are using k-means clustering algorithm. So we have to give it as k-means with the parameters like n clusters is equal to 3. So here we are going to divide the data into 3 clusters, and then random set is equal to 42, and then n init is equal to 10, for which we are going to predict the clusters for X scale dataset, right? And then we have to plot the figure for the clusters. So we already told that we are going to have 3 clusters. So in order to visualize that, we are going to use some plotting libraries such as matplotlib and seaborn. So plt dot figure of fixed size. This is the basic frame size, that is 8 and 5. And then sns dot count plot. This is a type of plotting. So we are using count plot here with the parameters like x is equal to cluster, data is equal to data, palette is equal to viridis. And these are all the color themes. Of course, data is equal to data means we are passing the data as the data. And then plt dot title, we are giving the title as cluster distribution, and then x label as cluster, and then y label as number of samples. And finally, when we give show here, we'll be able to see the cluster distribution of our dataset. So this is the x-axis, y-axis, cluster distribution. This is our title, and we see 3 types of cluster over here since we have given n is equal to 3. Coming to the dimensionality reduction, the same procedure. This section of code is the import statements necessary for our code section. So this contains all the import statements which are necessary for building our algorithm like pandas, numpy, matplotlib, standard scaler, and PCA. So in this dimensionality reduction, we are going to use a particular technique known as principal component analysis, that is PCA. So before getting into the code section, what is dimensionality reduction? Dimensionality reduction is nothing but reducing the dimension of the dataset. So when we are working with a high dimensional dataset, it leads to more computational complexity and many other complexities. So we have to reduce the dimensions on the dataset. So we'll use many algorithms for this, such as PCA, GDA, etc. and etc. So with the same steps, initially we are going to import the data into our workspace, and then this part of code is to remove the blinded or the string values from the target column PIC50 and replace it into a numerical data. This section of code is that we are going to take the mean of the whole PIC50 column and convert it into a appropriate numerical feature data for processing. And then Standard scaler, of course, to scale the values of the data set within the particular range. So once a standard scaler is imported, we need to fit the scalar and then pass numerical features. And once the PCA algorithm should be defined over here. So I'm giving a variable known as PCA, and PCA is our algorithm over here, and I'm giving the parameters as n components is equal to 2. That is, this PCA algorithm is going to use two principal components. That is, it is going to reduce two principal components. And then similar to the standard scaler, once a PCA algorithm is imported or used, it should be fit with the X scaled data. And then explained variance ratio. This should be given as, since we have declared it with the variable PCA dot explain underscore variance underscore ratio. So this is going to calculate the variance of the data set. Explain variance ratios that it is going to calculate the variance of the data set. And then we are going to print the explained variance ratio, and then total explained variance. Total explained variance is just the sum of the explained variance ratio. And then in order to view the complete reduced dimensionality data set, we are going to plot it using the appropriate plotting libraries such as Seaborn and Matplotlib. So here we are going to give the fixed size as 10,7, that is our basic frame size, and then we are going to plot the scatter plot over here using the PCA, passing the parameters of x, y, and then alpha. Alpha means the shade of the color, and then CMAP is viridis, and giving it as the plot title as data visualized in 2D space. X label as principal component 1 and Y label as principal component 2. And then on giving the show, we'll be able to see the graph given here. Before that, we are going to check or save the reduced data. So we have reduced the dimensions, right? So we have to save the data as reduced data. So here we are going to give it as, of course we have to save it through the data frames and then convert it into CSV. So we are using pd.data frame of, we are passing the above data set with columns PC1, PC and 2, because this is the reduced dimensions PC1 and PC2. And then we are going to convert the reduced data into a CSV file. So reduced data dot to underscore CSV of, we are naming it and giving it with the extension dot CSV, and then index is equal to false. So finally our results will be saved as reduced data underscore PCA dot CSV. So thank you for watching this video.